we'll practice vision. Thanks for coming out and appreciate it. Like Jim mentioned, what I would like to do is just kind of give you a little snapshot into kind of systems biology and what we're looking at. And so we'll have a little brief biology session here, and then I'll tie it up and show you kind of a few of the biomarker screenshots of some aspects of the panels. And so we'll do all that in about 10 or 15 minutes. So just to have a little bit of perspective and about the process of the body. So we're talking about a process, not an object. This is something we're all going to be born, we're all going to live our lives, and at some point we're going to die. This process is not just of our physiology is not just starting and ending with us, but it's started with past generations. It's going to keep changing and evolving with future generations. So we're an individual process that's part of a larger arc of process. And when you actually dig down into it, there's some fundamental life processes that are going on here. And to understand them starts to kind of put the control of your health back into your hands, because then you can kind of look at these biomarkers, understand where you're at. When we're looking at these physiologic biomarkers, there are things that we cannot see. To get good perspective to that, you want to know what your fitness parameters. That's one of the great aspects of CrossFit is that you're getting benchmarks. You know what where you stand from a performance perspective in various workouts. So that's interesting. No, that's on that thing. It's my hot. All the hot. When you're looking at the process, which will pop back up. So obviously we are organized Earth. So we have building blocks that are essential to how we operate, and that's gives some light to the importance of how we feed ourselves. So we're looking for energy production to fuel all of life processes. I'm going to dig in a little bit there and show you kind of a little bit into energetics, both on how we produce energy, and then a master regulatory gene, metabolic gene called PGC1 alpha, that's critical to running all of, critical to kind of generating mitochondria, which are the power plants that run and generate energy for us to do all the things in our life. System stressors are just kind of how we interact with our environment, specific to sports and athletics and fitness. It's basically, boils down to how much of things you're doing, how much overload that you're giving to the body, and then you recover and you adapt and you become fit. So, I'm always telling clients, you're never going to get into shape by exercising. You're only going to get into shape by overloading your body, having a high training volume, which is either a high amount of intensity or a long duration of exercise. We won't get into that, but you need to allow yourself to recover. And recovery is very important from a perspective of sleep, of what you put into your body to help you recover, and we'll kind of delve into that for just a second. And then systems biology, again, I'll show you this master regulatory gene and show you how different influences, such as your hormonal milieu, what kind of hormone levels you may have or may not have, how that affects genes, as well as the foods that you choose to consume as a fuel to fuel your body. They all kind of tie together, and it's obviously a very complex system. We'll kind of try to simplify it. Let's just focus on fuel production. So let's think of your body as an engine right now. So we have this fuel system. Interestingly, and I didn't know this when I was in medical school. They didn't care to teach us this, but it just turns out that when you're eating your fats, your carbs, and your proteins, those are called your macromolecules. They all have different biochemical pathways, but they all become pyruvate, which becomes acetyl-CoA. So no matter what you eat for an energy source, it's going to become something called acetyl-CoA. And acetyl-CoA is a molecule, it's a hub molecule that can drop into the mitochondria, your power plants, and generate your energy currency, ATP. And then, if you have enough ATP and you're not using your energy by work and movement and exercise, then the body is going to turn around this process, use some of the energy, and use the acetyl-CoA and build its own protein sources. its own carbohydrate sources such as glycogen, its own fats like triglycerides. Not in this slide, but in these biochemical processes, there's a fundamental process called methylation. And it's basically taking a carbon life unit. It's donated by a specific protein, amino acid methionine. It's donated to these biochemical reactions to change molecules into another molecule. So it happens billions of times every minute. When you increase your metabolic rate, it happens at a faster rate. It all takes B vitamins. So biochemically transforming fats to this acetyl-CoA, carbs, proteins, it costs you some B vitamins. Recycling the main methylator methionine costs B vitamins, specifically B12, B9, and B6. So it's really good to be able to look at what your methylation status is. We can do that by looking at a molecule called homocysteine, which is what methionine turns into once it donates its methyl group, and the body just has to recycle it back to methionine. It costs these B vitamins. So when looking further into the fuel system, so there's always the big debate, give me carbs to fuel my exercise. So how many people take in a lot of carbohydrates before they exercise to help give them a little bit of a boost while they're exercising? Nobody, because it's a paleo CrossFit community. Good. No, perfect. Yeah. So and I'll show you, and it's actually really smart. And it's good. It's a good move. So it turns out that, and I'll show you this in the next slide, I think. If you use fats, it's a really energy-rich source of fuel for you, but it's not as efficient. It's not as fast as carbohydrates are to becoming acetyl-CoA. It's a more convoluted journey. There's more acetyl-CoA that's produced per gram of fat. And the body's adaptation to this is to increase the number of power plants that are going to be able to make your energy. So the trade-off is between having high octane fuel or having more cylinders in your engine block. And so you can capitalize on this.
So Justin,
yes.
the side was the cylinders.
So you can consider the mitochondria as the cylinders essentially. So you can have a 6-cylinder engine running at 9,000 RPM on high octane carbs, or you can train yourself through fats to have a 12-cylinder engine that's running at a little bit lower RPM until you turn on the intensity. And then when you're looking at top-end fitness and performance, if you turn on and crank up the intensity, you will switch your fuel sourcing and start using your own glycogen stores. And so you will switch to a carb fuel source, but now you have twice as many cylinders to run that process, so you have more high-end ability when you get there, when you're working there.